Today and tomorrow we're going to study volume. Today we're going to start with prisms and pyramids. Tomorrow we'll go on to cylinders, spheres, and cones. So all the volume will be covered in 2 days. So any kind of volume. When we're finding the volume of anything, here I have a rectangular prism. What are we actually measuring when we find volume of a three-dimensional solid? Yes, sir? The amount of stuff you can put inside. That's correct to a certain degree. Does anybody know specifically what the actual measurement is? What the actual measurement is we are finding, when we're finding volume, the number of 1 unit by 1 unit by 1 unit cubes that we can put inside something. So if I have a rectangular prism, what I'm finding is the number of cubes I can put across the front of it. And sometimes it's not all the way across, right? Because we can get a decimal number. Then I'm also finding the number of cubes I can go deep in it. Come on. That one doesn't want, the fourth one doesn't want to work. There. And then how many cubes I can go high. How many I can stack up. Even if it's a cylindrical object, like a cylinder or a cone, what I'm still finding are the number of cubes I could put in there. Sometimes they're a fractional part of a cube. And that's what volume actually measures. So in order to find out those number of cubes, for a rectangular prism, you've probably had from a science class or maybe an earlier math class a generic formula given to you for the volume of a prism, or a rectangular prism. Does anybody remember what it could be? 3 dimensions. What do I do with those 3 numbers? Yeah, so what is it? You remember what it is? Blank times blank times blank. There you go. Louder, John. So the volume of a rectangular prism, or a cube, right? Except the length and width and the height are the same thing, was given to you as this in the past. We're going to expand upon that and come up with a formula that's a little more generic than this, but it can actually work for almost any three-dimensional solid. Well, to get to that, let's think about what we have here. I want to separate out this right here. L times W. That stands for length times width. If I look at just that right there, the length times the width, doesn't that stand for something else? Isn't that the formula for something else? Of a? You're right. Isn't this the formula for the area of a rectangle? It is. Now, let me get rid of all these cubes. What is the base shape right here in this rectangular prism? What is that? That's a rectangle. So really what I'm doing when I'm finding the volume in a rectangular prism is I'm finding the area of this rectangle, right? That'll tell me how many cubes I can put in one row across. Then I'm multiplying by the height. That tells me how many rows of those cubes I could have. So we come up with a more generic formula because this is the area of the base shape times the height. And in a rectangular prism, the base shape is a rectangle. To this, volume of a prism equals capital B times H. Now I want to remind you, the capital B, this stands for area of the base shape. In the rectangular prism, that shape was a rectangle, so that's why it was length times width. But I could technically use this for a cylinder, couldn't I? Yeah, what's the base shape in a cylinder? Circle. What's the area of a square? How do you find the area of a... Did I say square? No wonder you're looking at me here. What is the area of a circle? There you go. Louder. Pi r squared, right? So pi r squared gives you the area of the circle times height. Guess what the formula for the volume of a cylinder is? Pi r squared h. It's the area of the circle times how tall the cylinder is. Well, you'll see that tomorrow. So this is the area of the base shape. That's what the capital B stands for. And h is the height of the prism. Now we do this more generically. The whole point of this is not for something like that, but for something like this, a triangular prism. Or if we ended up with something like a pentagonal prism. Not all of them are going to be rectangular prisms. All right, let's go back to this for now, though. Following my very generic formula, how would I find the volume of this? Well, how would I find the area of the base shape? Here's the base shape right here. It is a rectangle. How would I find the area of that rectangle? 14 times 12, and then I'd multiply it by the height here, which is 25. Now I know it's simply length times width times height, isn't it? So does it matter which order I multiply these three? No, it doesn't. For any rectangular prism, it really doesn't matter. The only reason I'm stressing this is because I want you to think of area of the base shape times the height, because then it'll apply to any rectangular, any prism. All right. 14 times 12 times 25. 4,200. So it's 4,200, and in this case it's meters cubed, cubic meters, because it's 3 dimensions. Have you noticed whatever the exponent is on the label depends on how many dimensions you have? If you're finding area, this would be a 2, but since this is volume, volume is 3 dimensions, the exponent is a 3 to make it cubic meters. What is that shape called? That's a cube, right? No such thing as a square prism. How would I find the volume of this? 7 times 7 times 7, or 7 to the third power. Is this a rectangular prism? Yes. Specifically, though, since all the faces are squares, it's called a cube. That's where the term cubing something comes from. How do you find the volume of a cube? You multiply a number by itself 3 times. So 7 to the third power, 343 cubic feet. How about this one? That's a triangular prism. 343. 7 cubed is 343 cubic feet. This is a triangular prism. So what is my base shape here? If it's a triangular prism, it is a triangle. What's the formula for the area of a triangle? If you forget these, they are on the front of your formula sheets. On the bottom, on the front side, with chapters 4 and 6, those formulas. Formula for the area of a triangle, yes, times height divided by 2. So am I going to need this to do this? Yes, because I have a triangular prism, which you technically cannot. There we go. Now we can find it. We know that that's a right angle, so this 14 is the height and 9 is the base. So I can have base of 9 times the height of 14 divided by 2. That gives me what? The area of the base shape. Then what do I have to do with this? Very good. Times 25, because that's the height or length of the prism. All right, 9 times 14 is 126. Divided by 2 is 63. Times 25, which is 63 times 25 is 1575, 1,575 cubic centimeters. Thank you, Stacy. 1,575. Why did I use the 9 times the 14 divided by 2? Yeah, because that's the area of the base shape, which is a triangle. Good. A rectangular swimming pool is filled with 1,750 cubic feet of water. All right, before I go any further, this number represents what? Yeah, the volume of that, right? How do I know that? Well, it's cubic feet of water. The pool has a width of 14 feet, so that's my W, right? And the depth is 5 feet, which could also be the height, right? That'd be the height. Find the length. So I'm missing my L, correct? Yeah. Now some people, like me, I need pictures. That's even blue for us. Kind of looks like a swimming pool. Right? Put little ripples of water in here. Put a little flotation device for some kid. Anything else? Diving board. I knew somebody was going to say that. There's your little diving board. Okay, well, we're not going to get a slide because you know how well I draw, or don't. How well I don't draw. All right, so there's our pool. And now the newer fancy in-ground pools aren't rectangles. They used to be, but not anymore. So it says the width. So this would be the width of the pool. This would be the height of the pool. So the width is 14 feet, and the height here is 5 feet. They want us to find the length of the pool right here. Well, what do we know? We know all this water right in here is 1,750 cubic feet. Well, I know then that what? How would I find the volume of that? Well, I know that the length, whatever it is, times the width of 14 times 5 would give me this, 1,750. What does that look like? An equation with how many parts you don't know? 1. So that's an equation with one unknown, right? Can I simplify this first? 14 times 5 is what? 70. So 70 times L equals 1,750. How do I solve for L? Divide by 70. L equals 25. So the length of that pool is 25 feet. But all I did was use the formula that I know for the rectangular prism to find its volume, and then work backwards to find the L. Which is what we did in Chapter 3, right? We did. Now we're just applying some of that knowledge we've hopefully acquired to something else. All right, we have another figure we need to learn today. That's a pyramid, the volume of a pyramid. Now wait a second, look up here. If I do this and cover that up, what do I have the formula for now? Prism. What we just did, right? Isn't that the volume of a prism? B time area B, capital B, where that's the area of the base shape. Here, let's go back. I'll show you. There it is right there. So they're almost the same, right? Why is the 1/3 in front of that? Well, if this pyramid did not come to a point, what would I have? I'd have a prism, wouldn't I? So how are the volume of this pyramid related to a volume of a prism? It's 1/3 of it. So by coming to that vertex, what, you're losing 2/3. You'll see it's the same way with a cone tomorrow and a cylinder. Well, this is kind of hard to see, so. So really, I'm going to do the same thing I did when it was a prism, except at the end, I need to multiply by 1/3, or what else could I do? Divide by 3. If you divide by 3, it's going to give you the same answer, and there's fewer buttons to push on your calculator. Same as multiplying by 1/3. You don't have to use the fraction key then. Either one of these you can use. 1/3 times that, or the area of the base shape times the height. Okay, what is the base shape in this rectangular pyramid? It is a rectangle, 24 by 16. So what do I have to do with 24 and 16? Multiply them. 24 times 16. Then what do I do with that? Times 30. And what do I do with the whole amount? Divide it by 3. 24 times 16 times 30 divided by 3. 24 times 16 times 30 equals divided by 3. 3,840 cubic meters. I want to caution you. Most common mistake made when finding the volume of a pyramid will be the last step when you forget to divide by 3. It's the same mistake made when students forget to find, when you're finding the area of a triangle, to forget to divide by 2. If you forget to divide by 2 when you're finding the area of a triangle, you're actually finding the area of a rectangle. Here, if you forget to divide by 3, you're actually finding the volume of a prism. So be careful on this one. Make sure you get this last step right here to divide by 3. All right. Pages 454 and 455, 1 to 23 all.